All right, so hyperbolas is the last of the 4 conics. So circles, parabolas, ellipse, and hyperbolas are the 4 different conics that you'll be tested on, okay? The overall shape of a hyperbola is obviously different from the others, whereas you had a circle or a parabola or like the ellipse, which is like the oval. A hyperbola has 2 branches, is what they call them, okay, that point in opposite directions. By definition, it's the set of all points in a plane. The difference of whose distance from 2 distinct points, which are called the foci, is a positive constant. Just like an ellipse, it has a center, it has vertices, it has co-vertices, and it has foci. What's new is that it also has asymptotes. So it adds to what we know about the ellipse. Some vocab terms, it says the graph of the hyperbola has 2 distinct parts, which are called branches. So those parabola shapes are called branches, okay? The center is directly in between those 2. A is, again, the distance from the center to the vertices. The foci live inside the scoops just like it would in the parabola. And C is, again, the distance from the center to the foci. And then you'll determine how wide or narrow to make these branches based on B, which is going to give you the co-vertices. The line segment connecting the vertices is called the transverse axis. So this is what was formerly known as the major axis. Instead of major, it says transverse. And then the other one, which you're going to see in a second, is called a conjugate axis. So some new vocab terms. All right, so on a graph, okay, there's 2 ways your hyperbola can face. Horizontal, which means the branches point to the right and the left, and vertical, meaning they point up or down. So a couple things to kind of pay attention to. I'll zoom in on the horizontal one so we can talk about just that one first. So you've got your branches. You've got A, which represents the distance from the center to the branch, or to the vertex. So A, center to vertex. You've got B, which is, again, center to co-vertex. So nothing new there. And then you've got a C, which is center to focus. So all of that is the same as it is for an ellipse. A is center to vertex, B is center to co-vertex, and C is center to foci. Some of the vocab that changed is that the major axis becomes what's called a transverse axis. And the minor axis becomes what's called the conjugate. So if it says the transverse axis is 20 units long, then the transverse is just like your major, which would be 2A, and that tells you A is 10. If it says if it says the conjugate axis is 12 units long, then that tells you B is 6. So major, transverse, minor, conjugate. So if it's horizontal, we go right and left the A, we go right and left the C, we go up and down the B. And then I'm going to teach you how to make that little box, and we cross the asymptote through the corners of the box. If it's vertical, we go up and down the A, up and down the C, right and left the B. And then again, you'll make a little box. You'll have your asymptote slide through the corners of that box, and that tells you how wide or narrow to make your branches. Okay, what happens if I shift it off center? So if I shift it off center on the last pictures, the center was at 0, 0. If I shift it off center, then everything also just shifts. If it is horizontal, I still go right and left the A to get the vertices. It would just be from a center that's not at 0, 0. I would still go right and left the C to get the foci. And then up and down the B tells you how wide to make it. So what you don't see in this picture is the imaginary asymptotes and the box that form them. Here's your standard form of your horizontal hyperbola, and here is your vertical hyperbola. Notice what changed is there's now a minus between. And the A always comes first. So we'll add that on to the next one because that's where all the equations are. All right, so the top part of this is what I would say to memorize. The bottom part is just if center's at 0, 0, but you could just make H and K 0 and it stays the same. This time your A is first, not always bigger. So it could be bigger or smaller. What's important is that it comes first. If the X is over the A, so the X is first, then it's horizontal. If the Y comes over the A, so the Y is first, then it's vertical. On the bottom, you get the transverse axis is 2A, the conjugate axis is 2B. And in the middle here, C squared equals A squared plus B squared. So the most important things on that slide are, again, the top box. The C squared is equal to A squared plus B squared. Transverse is 2A, conjugate is 2B, and A is first. So the biggest difference between ellipse and hyperbola is the minus in between, and the C squared equals A squared plus B squared, and then obviously the shape, but the rest of it is pretty much the same thing. All right, so example 1 says find the standard form of the equation of the hyperbola with a foci at -1, 2 and 5, 2 and vertices at 0, 2 and 4, 2. So I'm going to draw it out. You could pull in a coordinate grid if you wanted to get really accurate, but I'm just going to kind of eyeball it. And I'm going to say -1, 2 is one of the foci, and 1, 2, 3, 4, 5, or one of the focuses, is the other one. Yeah, sure. So what do you know now? So I can find the center by doing the midpoint. Good. Center. I can add the 2x's, divide by 2, so it'd be 4 over 2 and 4 over 2. The center's at 2, 2. If you drew it accurately on a coordinate plane, you could also count that, like you would see halfway between would be 2, 2. That's your center. What else do you know? It's going to go point right and left, right? Which means this is horizontal, and if it's horizontal, what letter comes first? X. It's an x squared minus a y squared. So already I have x minus 2 squared minus y minus 2 squared. Both of those are going to go over something. Equals 1. How about between letters A, B, and C? What does the foci tell you?
C squared is 9.
Good. Okay, so foci is your C, and from center to the foci here, 1, 2, 3, 1, 2, 3. That tells you C is 3, which would make my C squared 9. And then they gave you another piece of information, that is the vertices are 0, 2, and 4, 2. So 0, 2 is a vertex, and 4, 2 is another vertex. This confirms it's horizontal, right? And what letter does a vertex give you? A, B, C. It is 2, but what letter is it? Is that A, the B, the C? The A. So A is 2. Now I got C squared equals A squared plus B squared because it's a hyperbola. So 3 squared equals 2 squared plus B squared. 9 equals 4 plus B squared. And B squared equals 5. I don't need to know what 5 is in order to get the equation. If it wanted you to draw it, I would need to know 5 is the square root. B is the square root of 5. But to plug it into the equation, I want it to be squared. So I'm just going to put the B under the second one because A always comes first. A squared would be 4. Questions so far? Yes, like an ellipse, this always has to equal 1. Okay, now we're going to talk about those asymptotes. So the asymptotes are used to tell you how wide or narrow to make your branches, okay? They pass through the corners of a rectangle in the dimensions of 2A by 2B with a center at HK. So what we're going to do is when we draw this, we're going to find our center. So let's say our center is at the vertex, at the origin. And let's say it's horizontal. I'm going to go to the right, whatever distance A is, the left, whatever distance A is. I'm going to go up whatever B is and down whatever B is. And then from those vertices and co-vertices, you're going to make a little rectangle. And through the corners of that rectangle, you're going to draw your asymptotes. So they would pass through the corners of the asymptotes. And then we said this was horizontal to begin with, so these are my vertices. I'm going to make my branches as wide as possible without hitting the asymptotes. If it was vertical, I'd put them on the top and the bottom. I would have gone up and down the A, right and left the B, made the little box, and then figured it out. The equations of those asymptotes can be found using these. So if it's a horizontal hyperbola, meaning the x would come first and it would point to the left and the right, then it is y equals k plus and minus b over a times x minus h. And if it is vertical, meaning that my branches point up or down, this would be a y squared minus x squared. Then what changes is the b over a becomes a over b. So it's the only thing that's different. They are both y equals k plus and minus, and then it's either b over a or a over b times x minus h. And they will look something like y equals 3 plus and minus 2/5 x plus 1. And that's in point slope form, and you can actually leave it alone. If you wanted to distribute it to get it into slope intercept so that you could graph it, you could. But I think it's easier to use the rectangle. Like, I think the box is easier. All right. Example 2 says sketch the hyperbola whose equation is 4x squared minus y squared equals 16. So what's the first thing we have to do? Good. It's got to be equal to 1, so I'm going to divide by 16. And simplify. I get x squared over 4 minus y squared over 16 equals 1. Now tell me what you know about the hyperbola.
The center is 0.
Good. Center 0, 0. What else? Horizontal or vertical? Horizontal, because the x comes first. And as soon as I know it's horizontal, and right next to it to remind myself, I write b over a, because that's going to help me when I do my asymptotes. So if it was vertical, it's a over b. If it's horizontal, it's b over a. What else do you know? What's your a squared? Nope. 4. It's the first one. So a is 2. The b squared is 16, which makes b 4. So I'm going to start with my center at 0, 0. See if it catches up. And then because it's horizontal, I'm going right and left my A. Again, A does not have to be bigger. This is not an ellipse. In an ellipse, A has to be bigger. In a hyperbola, that's not the case. So I'm going to go right and left 2 in plot points. That's my A. And I'm going to go up and down 4. That's my B. All right, so I went right and left the 2, which are your vertices. So negative 2, 0, and 2, 0. I went up and down the B, which was 4. So 0, 4, and 0, negative 4, my co-vertices. I'm going to make that little box. I'm going to find the corners of that box. And I'm going to draw dashed lines, because that's what asymptotes look like, through the corners of that box. And then we said this is horizontal, so my branches are going to be wide, or as wide as the asymptotes pointing to the left and to the right. Yeah.
So we don't have to find an asymptote with the equation.
Correct. So it'll ask you, let's say it just says graph. Absolutely no, you could use the box, and I think the box is easier, you're done. Even if it asks you, like, just personal preference, like even if it asks me for the asymptotes, I still use the box to graph it, and then I would write the equations of the asymptotes and not distribute. So like if it says find your asymptotes, which it will most likely, I mean on a test, you're going to get some that just have like graph, and you're going to have some that graph, give the vertices, the covertices, the foci, the asymptotes, right? And so this would be y equals k plus and minus. It's horizontal, so it's b over a x minus h. So y equals my k was 0, my b is 4, my a is 2, my x stays x, my h is also 0. And then I would just simplify it. Y equals plus and minus 2x. So this time, you don't really have to distribute because they're zeros. Let's say that there were values in there. You wouldn't have to distribute. You could use the boxes. If I do have it distributed, should it match with my graph? Yes, right? My b is at 0 because that would be my y-intercept. And my slope is up 2 and to the right 1. That should match what we drew. But you don't have to use it that way. All right, last thing we're going to find is c. Because it's a hyperbola, c squared equals a squared plus b squared. C squared would equal 4 plus 16, which is 20. And so C equals the square root of 20. If I was to graph this, and I'll be honest, usually I don't have you graph it because you can get the rest of the graph without it. But let's say we were to graph this. Square root of 20 is in between square root 16 and square root 25, right? So it's in between 4 and 5. I would go to the right about 4.5, plot a point. I'd go to the left about 4.5. And that's what your foci should look like. When you're given that answer, because that will be the other thing it asks for, it's going to ask for vertices, covertices, asymptotes, and foci. I just went right or left with it. So I'm taking my x, which is 0, adding and subtracting. The square root of 20 becomes 2 root 5. So this would be 2 root 5, 0, or plus and minus 2 root 5, 0, like that. Questions on that one? So like fast forward to your test next week, there's going to be some that are shorter that only ask you to graph, or they give you the information to only ask you for the equation. And then there's going to be some that have multiple parts. You're going to have a multiple part one that's an ellipse. You're going to have a multiple part one that's a hyperbola, like all the different conics, so that it asks you all those parts along the way. All right, we'll do this one and then we'll stop for the day. Put the equation into standard form, find the asymptotes, and then sketch the hyperbola given by 4x squared minus 3y squared plus 8x plus 16 equals 0. So what are you going to have to do? Complete the square. We're so good at it now, right? We're going to complete it. There's an x squared and an x. So if I group those together, there's only one y squared. So it's not like there's a y squared and a y. So I don't have to complete the square for the y. I'm going to bump the 16 to the other side. For the x squareds, I'm going to take out that 4. X squared plus 2x, leave that space. Minus 3y squared equals negative 16. And then I take the 2, divide it by 2, that's 1. Square it, it's 1. Add the 1 inside the parentheses. And I would normally go ahead and add it to the 16 on the other side of the parentheses, but I have to multiply by 4 first. So I'm adding 4. So in factored form, this would be 4, square root the x squared, I get x. Square root the 1, I get 1. Take the sign from the middle, which is a plus, put it in parentheses and square it. Minus 3y squared equals negative 12. What does your hyperbola have to equal? 1. So I'm going to divide everything by negative 12. And I'd get x plus 1 squared over negative 3 plus y squared over 4 equals 1. And that -3 is making that whole term negative, so we switch the order because our first one should be positive. Which is why you wait until it's in standard form to decide if this is vertical or horizontal, where your center is or anything like that. Because if I went off it at the beginning, my y was the one that was squared, which would imply that the y comes second, right? But that's because it wasn't in standard form yet. We get it into standard form, and then we make the decisions on it. So tell me what you know about this hyperbola now. Start with the center. Switch it. -1, 0. And that's going to get half of you on the test. So careful, right? Our brains say left to right is wrong. You got to look for the x. What's your a squared? Well, a squared is 4. A is 2, right? What's your b squared? 3. So b is the square root of 3. And is this vertical or horizontal? Vertical, which means what goes over what in my asymptote equation? Good. A over b. So it said, we're going to keep going, but it says find the asymptotes. So my asymptotes by equation form would be y equals k plus and minus a over b times x minus h. My k is 0. My a is 2. My b is square root 3. X minus the h is a -1, so that becomes +1. And then I have to simplify it. So I'm going to lose the 0, and I'm going to rationalize. So I get y equals plus and minus 2 root 3 over 3 times x plus 1. And I would say I definitely would not want to use that to graph it. I would try to approximate it and use the box. So I'm going to plot -1, 0 for my center. I'm going to go up and down A, which is 2. Which would have been my vertices had it asked for it. They would have been at -1, 2, and -1, -2. I'm going to go right and left square root 3. So square root 3 is like a 1.7. I'm going to approximate it 1.7 to the right, 1.7 to the left. I'm going to make the little box. I'm going to find the corners. I'm going to pass the asymptotes through them. And then it's vertical. So we're going up and down, making them as wide as those asymptotes. Questions? If you want to wait till tomorrow, it's the same as an ellipse. It's C over A. Okay, if that's going to be one of the parts it's going to ask you for. The difference is instead of it being nice circular shape, it makes it more narrow or more wide. Okay, the larger the E, the wider the branch. The smaller the E, the more narrow the branch. That's the only difference. Okay. And then again, we'll finish the rest of the examples tomorrow. But you can go through on your website and you can start anything that's graphing, that's finding the vertices, the covertices, the asymptotes, and now is eccentricity. It's just C over A.